Hi, let's take a look at a hex editor. This one is called Hex Workshop. They're all very similar. They all do similar things. What a hex editor does is it allows you to see the actual bits. As I told you earlier, everything stored on the computer is stored as logically a sequence of zeros and ones. This allows us to see what the actual bits look like. So let's take a look at this one. So let's take a look at a file. Let's choose a doc file. So what are we looking at? Actually, when you first start up your hex editor, if you're using Hex Workshop, you'll actually see this window open as well. We're not really going to use the data inspector window, so you can just click on the little X and get rid of that. So what we're left with here are three basic panes. What's on the far left here, these are addresses. So the address of this D0 is all zeros, plus this last digit here at the top is the last digit of the address. Computer addresses are much like a house address. If you go to house address, you know who lives there. It's much like on the computer. If we know the computer address, we know what file or whatever is stored there. So what's here in the middle pane, this is the data. And what's over here in the right pane, this is the data if it's a character. So you can see most all of these aren't actual characters. If we come down here, we can see where the actual text is. This is the text. This is actually my CV. But this is the text. So what else is in here? Well, these first few digits, the D0, CF, 11, E0, A1, B1, 1A, E1, this is the signature of a Microsoft Office 2003 file. So this tells the computer that this is an Office file 2003. So I'm coming down here. Again, this is the text. The stuff between the signature and the text is just what we call padding. Depending on what options you choose in Microsoft Word, there may or may not be something stored here. Then we have our text, and after that, after the text, you see a bunch more padding. There's also some information here about the font we're using and the structure of the document. Basically metadata, data about the data about this document. And then at the very end, there's more padding. As you're going to see in the second assignment, sometimes we can use this padding to store hidden information. But again, you have to find it out yourself on assignment 2. So again, all files are stored just as zeros and ones from our perspective using a hex editor as hexadecimal. So to prove that, let's take a look at another file. This is a JPEG file. This is an image file. If you look down here, this doesn't look too much like an image, but this is what represents the image that we're looking at. Again, these first few digits, hexadecimal digits, tell the computer that this is an image file and a JPEG in particular. So let's take a look at a zip file. This is a compressed file. Again, these first few digits tell the computer that this is a zip file. And if you come down here, you'll see there's nothing but a bunch of gobbledygook. So let's take a look at a PDF file. The PDF part here and over here tells us, the computer, this is a PDF file. Not a lot here that's readable from our perspective. And then at the very end, there's this EOF. This tells the computer this is the end of the PDF file. Some documents or some types of documents have end of files trailers and others don't. PDFs do have an end of file. So let's look at application. So this is a program. We can read a bit of text that tells us the program can't be run in DOS mode. But other than that, just a bunch of zeros and ones that is what the program executes. This is what machine language looks like. This is what all programs look like from the bit level. So let's go back to my CV again. We can actually type in here and make changes. So let's come down to here. Let's take a look at, say, this O. If I click by the O, you can see that this 4F is highlighted over in the data part. So this tells us that 4F is the ASCII representation for capital O. If we look at the N, 6E is the ASCII representation for small n. And if you look at an ASCII chart, it'll tell you the same thing. So we can change some of this. We can actually type right into the data part as long as we use hexadecimal numbers. So we could say 6B. And when we do that, you'll see that it has changed the character over the character part. Another option is to type right in here. Let's take a look at this C here. Let's type it in S. And you'll see the 73 has been highlighted. So tells us that we've changed this character into 73, which represents lowercase s. So we can actually type using the hexadecimal editor. We can alter documents. So one thing that we want to be able to prove, say, to a judge in a courtroom setting is that the document hasn't been altered. So we can do that by using what's called a checksum. So if you go over here under Tools, click on Tools, and Generate Checksum, you'll see there's lots and lots of options here. So let's choose one. Let's just choose, well, the one that's highlighted, SHA 160-bit. 160-bit just tells us how long that the key is. So we'll generate. So this is the checksum. CB629F37 and so on. So let's make a change and see what happens to the checksum. So let's just come up here and let's just change one of these to whatever we like. So we've just changed one character. So let's see what this does to the checksum. Again, the old one started with CB629. So now if you run the checksum, being sure to use the same algorithm, the SHA 160-bit, for the entire document, generate the checksum, and now we can see the checksum has totally changed. So by just altering one digit, the checksum is totally different. So we can use this in court to prove that the copy that, say, we analyzed in the lab is exactly the same as the copy of the document or even the hard drive that we seized from the suspect. We can actually work on a disk level. We can look at a whole disk drive, although the demo version that you're using is not going to allow us to do this. But this is a hex editor. These can be very, very useful in computer forensics.